Alright, YouTube, here we are. I don't usually record pre-tests, but the pre-test review today was a little bit rushed or shortened, I guess, because of YouTube Wednesday. So, we did 2 and 4 in class. Let's do like we did in class. We'll start with 4. Go backwards, okay? And by the way, here is the question. Here it is. Page 4. Alright. So, the data in the accompanying table gives the yield Y in milligrams of a chemical reaction after T minutes. And so, in other words, after 1 minute, we get 1.5 milligrams of reactant. After 2 minutes, we get 7.4 milligrams of reactant. And in 3 minutes, we produce 10.2 milligrams of reactant in our chemistry lab, right? Part A, find the line of best fit. Do a linear regression. Part B, find the log of best fit. The logarithmic curve of best fit, or logarithmic regression. Part C, which one's better, and use it to find Y of 10. All right, let's do that. Now to do that, you enter this data into the calculator. All right, let's see. I don't know if I have a calculator open. Let's find the calculator. Okay. And that's not it. Okay, so I'm going to clear this. And I'm going to put stat plot on, because we're going to do stat edit. If stat plot is on, zoom stat will automatically give you a good window for your scatter plot. Notice what I got here. The type is a scatter plot. I'm going to enter the data into L1 and L2, like X's and Y's, or in this case, T's and Y's. And the mark is whatever you like, and the color is whatever you like. I don't care. Then, second quit that. How about stat? Well, second quit that. Clear this. Okay, stat. Okay. Edit. There you go. And here's the data already. Now, say you don't have the data already. Wait, let me make this a little bigger. All right, say this isn't the right data. You go to the top of the screen, clear, enter, starts fresh, right? And then you just type it in. 1, enter, 2, enter, 3, enter, 4, 5, enter, 6, enter, 7, enter, 8. Okay, there you go. And then you copy the data that was given in the table over here, right? The 1.5, the 7.4, the 10.2. I'm putting that into L1. Sorry, L2. All right, so how do you see the scatter plot? You just do zoom stat, zoom 9. That sets up the X min and X max and Y min and Y max automatically, so you can see all the points from making points out of L1, L2. The points being 1, 1.5, 2, 7.4, and you can even trace that if you want. All right, so that's part A, entering the data. Now, let's find the line of best fit, the linear regression. Okay, so let's go to second quit this, stat, calc. Now 4 and 8 are really the same thing. So some people like mx plus b, that's 4, but they call it a instead of m. Some people like to write b plus mx. Well, in this case, the b is the slope, right? So in 8, the b is a slope. In 4, the a is a slope. That's the only difference. It's really not a big deal. So 4 or 8, I don't care. Pick 4. And so are we using L1 and L2? Yes. Now, it's going to give me the answer, a whole ton of decimals. I don't want to have to type them all in. If I want to graph it in Y1, I'm going to make it, copy it into Y1 for me. So vars, Y vars, function 1. And then go to calculate. And this is what do you write on your paper? You write that Y dot equals, because we're rounding off, dot equals what? 2.289x plus 2.336. Just fill in the A and fill in the B. And also give me the R squared. The R squared is the coefficient of determination. It's really hard for that to be 100%. So I'd like to write that down and see if I can get as close to 100% as possible. So how do you write R squared as a percent? 0.90056 something is 90.056%. So that's what you write on your paper. All right, so let's see. That would be 4A, right? Okay, let me write this down somewhere. So we're writing that Y is approximately 2.289x plus 2.336, and R squared is approximately 90.056. So let's write that down. This is how you show your work. In 4A, you write that Y is approximately what we got, 2.289x, that's your AX plus B. B is 2.336. And R squared is approximately 90.056. 90.056%. So is that any good? Well, go back to the calculator and graph it. Now it's graphing y1 is the answer that we just got, the line of best fit. But it's not a great fit. It hardly touches any of the points. It's pretty far from most of the points. That's not great. But look at the, if you actually drew by hand a curve yourself that went through all these dots, doesn't it look like a log? Take a look at part B. Part B says, okay, find the log of best fit. Do a logarithmic regression. So quit this, second mode is quit, and do stat calc. Now, which one of these has to do with logs? Don't say 7 or 8. That's linear. That's not logs. 9, ln, logarithmic. And by the way, don't say, some people get messed up today, that's exponential, that's power, that's logistic, that's something weird. We haven't talked about that. And that's sine regression. We did these. Remember we did sine reg and lin reg before? This should be reviewed, except we're using ln reg if it looks logarithmic, or exp reg if it looks exponential. Take a look at screencast 508, which I put up on Edmodo, which gives you an example of an exp reg. But right now we're doing a lin reg. There you go. So we're doing L1, L2 again. And if you type y1 here, it's going to write over what you have in y1. If you want to do that, that's fine. But I'm not going to type over y1. So how about vars, y vars, function 2, enter, enter. And now what do you write? You write that y is approximately a, which is 1.538, plus b, which is approximately 2.373, 8.373 times the ln of x. And your r squared now is about, as a percent, what do you write? 99.349%. That's a lot better. That's almost 100%. That's as good as it gets, 100%, right? You're real close. So this has got to look better if you graph it. Let's see, graph it. Remember, you're in Zoom 9, so you have a good window already. That only works if you have stat plot on. And that's not good, but this is good. I like this. This is pretty good. All right, so it's 99% coefficient of determination. That's good. Okay. So part C says, what does it say? It says, find y of 10 using your best regression. Well, it's the logarithmic one, the one we put in y2, right? So I want y2 plug in 10. Easy. Let's see. y2 plug in 10. So second quick, get on your home screen. Do vars, y vars, function 2, plug in 10. There you go, done. Okay, so that's the answer. Now be careful, there's units in the question, there's units in the answer. The 10 is a t, that's in minutes. The y value we just got, 20.818, is the yield of the reactant, so that's in milligrams, right? So what do you write for your answer? You write 20.818 milligrams. Okay, let's write that. So, oh, I didn't write 4b. Okay, let's write 4b while we're at it. 4b was just writing out the logarithmic regression. So y is about 1.538 plus 8.373 ln of x times ln of x, right? And r squared is about 99.349%. And so if we plug in 10 into that last regression, we get about 20 point, what was it? I had it here. 20.818 milligrams, right? 20.818 milligrams. All right, that's part C. Now look, if you jump to part E for a second, it says interpret the results in 5C, 5 to 5D. You see choice 4E? That's a typo. It should say interpret your results in 4C and 4D. Now actually, I don't really care if you do 4C and 4D, just give me one of them. What does this say? What is this asking? It's asking for you to say in English what your answer means, what your numbers are. Okay? So, say in English what y of 10 equals 10.818 milligrams, what that means. Just write it in English, okay? So, how are we going to do this? All right, I'll just put 4E here. Okay, 4E. So let's just restate what it says here, okay? It takes 10 minutes to produce 28.818 milligrams of product, output, reactant, whatever we want to call it. Anyone taking Regents Chem, AP Chem? All right, so just write something in English. Now, you could do that for 4D instead. You don't have to do it both. Just give me one sentence in 4E, that's fine. So now, what is 4D saying? Let's see, what's 4D? Use the best regression, again, it's going to be the log in this case, to solve the equation y of t equals 20. So notice, we're not plugging 20 into y. We're making y 20 and plugging and solving for t or x on the calculator. So this is really easy. To do this on the calculator, all you do is this, right? Hang on. Let's write down what we're going to do. We have that y is about 1 point, the logarithmic regression, 538 plus 8.373 ln of x, right? That's what y is. I want to find the x value, or the t value. It's really the t column, not the x column. When y is 20. So you could solve that algebraically, but that's sort of silly because this is an approximation already. So how about you just take your y2, which was your logarithmic regression, and then put in your calculator y3 is 20. Set one side equal to y3, set the other side equal to y2, and find the point of intersection. We're finding the x value in this equation, or the t value on the table. All right, so let's do that. On the calculator. Whoops, calculator. Let's get another y value. So I want to know when y2, the logarithmic expansion, or regression, right? This is the log answer. Notice it ends in ln x, doesn't it? Where is it? There it is, see? All right, I want to know when it equals 20. All right, so we can do this graphically. So, graph. Now the thing is, I want to know where the red curve hits the black curve. It's a little bit off the screen, so what's bad? X min, X max, Y min, Y max. X max has to be a little bit bigger, all right. So this window was automatically generated when you had stat plot on and you did zoom 9. All right. So now let's change it. My x max has to be a little bit bigger. How about 10? All right. So I don't care about the linear regression. The line of best fit was not that great. Here's your logarithmic regression. The log of best fit. The log curve of best fit. There he goes. It looks like an ln sort of. And where the red curve hits the black curve, that's the point of intersection I'm looking for. So second trace 5. Do I want the blue curve? Notice where the cursor is. No. So up or down arrow will change to another one of the curves. Do I want the red curve? Yeah, I do want the log. Enter. Now look, it's on the black curve. Do I want the black curve? Yeah, it's the red and black intersection. Enter. Then I don't have to guess. There's only one point of intersection, so there you go. So the answer is 9.069-ish. And so say so. So x is about 9.069, and x is really the t value, minutes. Now what if you use D to do E? You could do C or D to do E. You don't need both. How would you rewrite D? To get 20 milligrams of reactant, you have to wait 9.069 minutes. How about that? Something like that. Okay? So either one for E. Write one sentence. Okay? That's enough. Okay? All right, there you go. Then we did number 2. All right, let's do the same thing we did in class. So let's go to number 2. Let's see, number 2 looks like this. The number of miles S, this is a function S of H, okay? S is like your Y value, your output. H is like your X value, your input, okay? So the number of miles S of roads cleared of snow each hour a plow is in use, like a truck during the snowstorm, is approximated by this model where H is between 2 and 15, and H is the depth of snow in inches. Notice where it says H over 12, we're really plugging in feet into the ln, right? Okay, find S of 2, find S of 15, and part D, interpret your results of A, B, or C. So rewrite one of those as a sentence. What you get in A and B or C, right? All right, so how do you do A? You just plug in 2 where you see H, right? Okay, so let's do that. All right, so here's question 2. All right, so 2A. 2A says, what's S of 2? Well, S of 2 is plug in 2 where you see H. 25 minus 13 ln of H over 12, but I'm plugging in 2 for H. That over ln of 3. Not the 25, though. Be careful. Punch that into your calculator, and you're done. All right, so get to the calculator. And wait, where's my calculator? Why is this doing this? Okay, so second quit, and let's just type it. Clear this. All right, so let's see. It's 25 minus. How about we do an alpha y equals 1 to make the fraction easy to input? Otherwise, you need a lot of parentheses. 13 ln. And there's another fraction. Okay, alpha y equals 1 again of h over 12, but I'm plugging in 2 for h over 12. Okay, get out of the fraction, close the ln. And then the denominator here was an ln of 3. And what do you get? 46.202. So now, what if you, that was part A. What if you use that to do part D? Again, I just need one sentence for A, B, or C. That's enough. I'll let your English teacher know that you know some English. That's we're happy. So what do you write here? If there's 2 inches of snow on the road, that's the 2 in the 2/12, right? Then you can plow 46.202 miles of road each hour. That's how fast your truck is going. That's it. So write something like that. Okay, so what is it? 46.202? All right, so how do you write this? Let's see. 46.202 miles. Don't forget, if there's units in the question, there's units in the answer. And if you know that the 46.202 is in miles, and you know that the 2 is in inches of snow on the road, it's real easy to do 2D, right? Let me do 2D right now. Right? If there's 2 inches of snow on the road, we can plow 46.202 miles of road per hour. How about miles per hour? How about that? But it's miles of road, right? How much snow-covered road that has 2 inches of snow on it. So the idea is this: if you have more inches of snow, you're plowing less per hour. Your truck will go slower, right? All right, let's see if that's true. Take a look at 2B. What if you had more inches of snow? 15 inches of snow. That's a hefty amount of snow. That's a big storm, right? All right, let's do the same calculation. Here we go. So let's go to 2B, which says, what is S of 15? Do the same thing you did for part A. It's 25 minus 13 ln of 15/12 over ln of 3. So let's approximate that many miles, right? Let's get the calculator out. And let's do that. Well, it's the same calculation, right? Let's just change the 2 in here to a 15. And you get 22.356 miles. Okay, so write that. 22.356 miles of road per hour, whatever. You could write miles per hour, I guess, there. All right, then, part C. What's different about part C? It says solve for h if S of h is 50. So we're not plugging in 50 for h like we did in A and B. We're plugging in 50 for S and solving for h. It's like we're setting y1 equal to 50 and y2 equal to the function on the calculator, see where the point of intersection is, and that's exactly what we're going to do. All right, so let's go to the calculator. Where did my calculator go? There it is. All right, so go to y equals. You know what? The stat plot messes up here, so I don't want it. The second stat plot plots off. All right, let's clear all this stuff. Go to y equals. Okay, so, and clear this. This has nothing to do with this problem. All right, so one side of the equation was 50. The other side of the equation was 25 minus, well, okay, why don't we do the alpha windows? Alpha, y equals, just be careful of the parentheses if you don't do the alpha window. 1 of 13 ln, okay, alpha window 1. Alpha y equals, actually, I should say. Alpha y equals 1. Now, it's in function mode, so I can't use h here, I got to use x. Over 12. And that, just that, not the 25, is over ln of 3. Now, what's a good window? Well, remember what we just got. Let's see, let's think about this. When we plugged in 15, we got 22. So, like, x is 15 and y is 22. And when we plugged in 2, we got 46. Okay. So the x values are, between 2 and 25, something bigger than 25 for x max. You're not going to have negative inches of snow, right? So x min is 0. Y max has to be at least 46, but don't forget y1 is 50. I want to see y equals 50 as a horizontal line, so y max is a little bit more than 60. So how about, I don't know, 0 to, what are the x values? 0 to like 15, all right, 0 to 20 for x min, x max, and 0 to 60 for y min, y max? Okay, let's do that. So, window, there it is, 0 to 20, and 2 tick marks, okay, that's fine, and 0 to 60, and 6 tick marks, okay, let's see what that looks like. So y equals 50 to that horizontal line right there, and y equals 25 minus 13 ln of x over 12 all over ln of 3 is the red curve, and I just want to know where they intersect, right? Is this terrible? All right, so super trace, second trace, whoops, second trace, intersect. Now there's only 2 curves here, so enter, enter, and there's only one point of intersection, so enter. 1.451 inches. Okay, let's write that down. So if we set the function given, 25 minus 13 ln of h over 12 over ln of 3 equal to 50, we got h was approximately, oh gosh, what was it? Where is it? Where'd it go? That's not it. Where did it go? There it is. 1.451. 1.451. Don't forget, inches of snow on the road. So if you wanted to write that as your part D answer, you would say, if you're plowing 50 miles per hour, 50 miles of road every hour, then there's only about 1.451 inches of snow on the road, right? Okay, now part E is to graph. So just graph what you did for the point of intersection stuff. Just graph that. Oops, sorry, where'd that come from? All right, so this was 0 to 20 on the bottom, and this was 0 to 60 on the top. And just graph that and label the point of intersection, and you're done. That shows us how you solved part C, right? All righty, so let's do that. It doesn't have to be beautiful. Look, here it is. 2E. 2 here. 2E. All right, so 20 for H, like X on the calculator. 60 for S, like Y in the calculator. You had a horizontal line at S equals 50. And then you had this crazy curve like this. All right, and this was S equals 25 minus 13 ln of H over 12 over ln of 3. And why not label the point of intersection just to show you work for 2C? 1.451 comma 50 approximately. Remember, the point of intersection, we already knew the Y value was 50, right, the ordinate. What we want is the abscissa, the H value, 1.451 inches. And that's number 2 done, okay? Alrighty, now, let's take a look at number 3. Okay, here we go, number 3. All right, now this is what we didn't get to do in class. Where did it go? There it is, number 3. This is like PERT, okay? And if it's not PERT, it's that other formula, P0 times 1 plus R over N to the NT. Or it's PERT, P0 times E to the RT. All right, so a deposit of $750 is made in a savings account for which the interest is compounded continuously. That's PERT. P of T equals P0, E to the RT. The balance doubles in 7.75 years. What's the annual percentage rate? Okay. And you're depositing $750 to begin with. Okay. So here's number 3. 3A. Well, if P of T, your amount of money, your principal in dollars, over a period of time T in years, is P0, the initial deposit, E to the RT, they gave you P0. You're starting off with $750. And they gave you that it takes 7.75 years to double. So plug in 7.75 for T, and you still know R. And if it doubles, don't you have $1,500? So we're looking for the rate at which the doubling time is 7.75 years, right? So how do you solve this equation for R? Divide both sides by 750, and ln both sides, and then divide. R is the ln of 2 divided by 7.75. What is that? Let's see on the calculator how big that interest rate is. ln of 2 over 7.75. ln of 2 over 7.75 is 0.08943. Now, if you want, you should really write that as a percent. The annual percentage rate for continuously compounded interest is 8.944%. 8.944%. There you go. That's part A. Part B is bonus. Read the book. You can figure that out if you want to do bonus. By the way, finishing 1 and 3 is your homework check-in on Friday. I'm not here tomorrow. Find the balance after 10 years. Okay. Well, now what's going on is, this is 3C, 3B is bonus. See if you can figure it out on your own. Now you have that P of T is P0 e to the RT, but R is exactly this. Let's write it exactly, not round it off. All right, so they want to know what's the balance after 10 years. In other words, T is 10. Remember, it doubled in 7.75 years, so it's going to be more than double, right? So type that in your calculator. Okay, let's do it. All right, so it's going to be 750 times e to the second ln. Let's see how we're going to write this. How about the ln of 2 divided by 7.75 times t. There you go. So you get more than $1,500. $1,834.37. Let's round it off to the nearest cent. $1,834.37. Don't forget units. Dollars. All right, part D. When will the balance be $3,000? All right, so in other words, we're not plugging into T, we're plugging in for P. We want to solve for T when P is 3,000. So 3D, let P of T become 3,000 and solve this equation for T. And you could do this graphically, but it's not that hard to do algebraically. If you divide 750 into 3,000, doesn't it go 4 times? Now, wait a minute. So that's another doubling time? So if it doubles from 750 to 1,500 in 7.75 years, then it doubles again from 1,500 to 3,000 in another 7.75 years. So all you really have to do is this. But if, say, you didn't see that, ln both sides. And divide by this number in front of the t, or multiply the reciprocal. So t is 7.75 over the ln of 2 times the ln of 4. Now think of it. ln of 4 is ln of 2 to the 2. What do logs do to exponents? ln of 2 to the 2 is 2 ln 2. 2 ln 2 divided by ln 2 is 2 times 7.75 is again 15.5. And again, if you don't see it, years by the way, if you don't see it, do it on the calculator. 7.75 divided by ln 2 times ln of 4. Okay? 7.75 divided by ln of 2 times ln of 4 is 15.5 years. There, it's perfect. Okay. Now part E. Part E is not as obvious. Part E says, all right, when is P $10,000? How long do you have to wait? You have to wait 15.5 years to get $3,000 from this investment, right? Now, in part E, how long does it take to get $10,000? 10,000 equals 750 e to the ln of 2 over 7.75t. And you can do all the same stuff all over again, or you could do it graphically. If you do it graphically, you got to draw a graph as part of your work, okay? But let's see. What if we did this graphically in the calculator? Let y1 equal 10,000. Let y2 equal 750 e to the ln 2 over 775t, and see what you get. Or you could do it algebraically like we did in 3D. Okay, so let me clear all this stuff. Go to y equals, let me clear all this stuff. All right, so I want to know when I get 10,000. And I want the initial deposit to be 750, e to the, and this is ln of 2 divided by 7.75 times x, because I can't use t in function mode on the calculator. And what's a good window? Well, remember, we're starting with 750, and it doubles in 7.75 years to 1,500. And then it doubles again in 15.5 years total to 3,000. So y max is more than 3,000, and x max is more than 15.5 years. I want 10,000 bucks. That's going to take a while. So, all right, window. From 0 to 15.5, it got 3,000. How about, let's say I don't know the answer. Say, I don't know, 40 years. And 4 tick marks. Okay. And then I want to get to 10,000. So how about 0 to more than 10,000? I don't know, 15,000. How about 15 tick marks? So there's y equals 10,000. And there's y equals 750 e to the ln of 2 over 7.75t. And where's that intersection point? Okay, so let's find out. Second trace, intersect. And there's only 2 curves here, so enter, enter. And you're near the point of intersection you want. Now, you're not near another point of intersection you don't want, enter. And you get 28.961 years, okay? So t is approximately 28.961 years. But how do you show the work? You draw the graph. Here's y equals 10,000, or p equals 10,000. That's 15,000, 10,000, 5,000. It's doing like this. And label this point. What is it now? It's 28.961, comma 10,000. That shows your work. Unless you do it algebraically like you did in part D. You can do that. Same steps. All right, so that was 3 we didn't get to do in class. You might want to do this for homework checking on Friday. And number 1. All right, number 1. Did we do this whole thing? What's the end percentage rate? We got the R was 8.944%, or ln of 2 over 7.55, or 7.75, that is. B, read the book, extra credit on the test, if you can figure that out. It's actually not that hard. Then 3C, we plugged in 10 for T, and found P, and then 3D, we made P equal to 3,000 solve for T, and part E, we made P equal to 10,000 solve for T, and there you go. All right, so number 1. Let f of t equal c e to the kt. It's almost like PERT. Instead of P0, you have C. Instead of R, you have K. Big deal. Given that f of 0 is a half, or 0.5, and f of 5 is 5, can you figure out C and can you figure out K? Okay. Here we go. 1A. All right, so f of t is C e to the kt. This is sort of like PERT. Don't get upset. All right, can you find C? Well, notice what they're telling you. F of 0 is 0.5. In other words, the curve goes through the point 0, comma 0.5. When t is 0, f is 0.5. And it goes through the point 5,5. F of 5 is 5, or the point 5,5 is on the curve. In other words, you plug in 5 for t, you get 5 for f. All right, so what if we plugged in the first one? If f is 0.5 when t is 0, that's a nice way to start, because 0 times k is 0. You don't have to worry about the k anymore. E to the 0 is 1, and c is 0.5. All right, fine. Now, rewrite. That's how you found c. That's it, right? That's part A. All right, so what's part C is 0.5, because it's C times e to the 0. All right, and e to the 0 is 1. Now 1b, whoops, 1b, can you find k? Well, now f of t is 0.5 e to the kt, because I already know c, right? Now plug in the other point, 5, 5. When f is 5, t is 5. Can you get k from that? Let's see, divide both sides by half. How do you divide by half? 0.5. You multiply by 2. Right, the reciprocal. How do you get rid of e to the ln? How do you get rid of the 5? It's multiplying, so you divide. And there's your k. And if you want a decimal version of that, go to the calculator. You don't really need it right now, but ln of 10 over 5 is 0.461-ish. Now don't use this rounded off value in parts, C, D, and E, because that's going to give you double round off error. Don't do that. Now what's part C? Part C says, what's the doubling time? Okay. So let's find out. Now we know, look what we know. Now that we know C is 0.5 and K is the ln of 10 over 5, I could say that f of t is C, which is 0.5, e to the k, which is ln of 10 all over 5, t. And how do you figure out the doubling time? Well, the initial amount is 0.5. If you plug in t equals 0, you got 0.5. So if you double it, that's 1. They want t when you get 1. That's how you get doubling time. Double the initial amount, right? And solve for t. Make that your y value and solve for x. Sort of, right? Let's see where to go. All right, so divide both sides by 0.5. In other words, multiply by 2 over 1, and you get 2. How do you get rid of the ln? Sorry, the e to the? Use ln. How do you get rid of the number in front of the t? You divide by it. It's a fraction multiplied by the reciprocal. Now they don't give you any units here, so you don't know what the units of t is or f is, but I don't know, maybe it's years or something. Can you give me a decimal version of that? Go to the calculator. ln of 2 over ln of 10. Where's the calculator? Okay, so ln of 2 over, wait, what was it? Sorry. It was 5 ln of 2 over ln of 10. 5 ln of 2 divided by ln of 10, unless you want to use the alpha y equals stuff. And you get the doubling time is 1.505 years or something, whatever it is. They don't give you units, so I'm not going to say years, days, weeks, hours, minutes, seconds, I don't know what it is. But it's a time, right? Alrighty, now. What's D? That was D. Okay. What's D? Interpolate f of 1, f of 2, f of 4, and extrapolate f of 8. Now remember what extrapolate is. Go beyond the domain that you know. I know f of 0 and I know f of 5. The domain is 0 to 5. If I try to get f of 8, I'm extrapolating and going beyond the domain. That's not considered accurate because what if this model fails later on? But between 0 and 5 for t, or for x on the calculator, that's considered more accurate. We call that interpolating. So we're going to just fill in the table of values for 2, 1, 2, 4, and 8. That's all. So this is what you do. Make a little table. For t is 1, 2, what was it? 1, 2, 4, and 8. Figure out f of t, which was 0.5 e to the ln of 10 over 5t. So just plug in 1, plug in 2, plug in 4, plug in 8, and see what you get. Alrighty. Oh wait, is that what we had? 0.5, what is it now? 0.5 e to the ln of 10 over 5t. That's exactly what it's there. Alright, so put that in the calculator. Here we go. Alright, so You know, for fun, why don't we put it into y equals? Clear this, put in 0.5 e to the ln of 10. You could do an alpha y equals for this, I guess, if you want, over 5 times x. All right, so it starts at 0.5, it doubles in 1.5 years or something. You could graph this. I don't know, let's do a zoom 4. I don't think zoom 4 is probably okay. All right, so we got to figure out the y value at 1, at 2, at 4, and at 8. You could trace it on here, or since I put this in y1, vars, y vars, function 1 of 2. Remember this does not mean multiply 2 times y1. This means plug 2 into the function that's stored in y1. All right, y4, y1 at 4, and y1 at 8, wasn't it? Oops, what am I doing? All right, so you write that down in a little table. Let's see. All right, so what is it? 0.792-ish, 1.256-ish, 3.155-ish, and 19.905-ish. All right, so this is what you write on your paper. Just fill in the table. And you're done. All right, so we did all 4 questions, 2 of them in class and 2 more now out of class. And that's enough for today. Bye-bye, YouTube. I hope that helps your study for the test on Friday on Chapter 5, Logarithms and Exponentials and Inverse Functions and Regression and Nonlinear Regression. Fun. Okay, bye-bye.